Hello everyone, welcome to our channel Code Arcade. In this video, we are going to talk about structures in C. We are going to see what is structures, why do we use structures, and where do we use it. Structures are nothing but user-defined data types. Using structures, we can define data type which can hold more than one element of different type. So structures are nothing but a user-defined data type. Unlike primitive data types such as int, and user-defined data types, it's a collection of more than one words. Okay, and using structures, we can define data types which can hold more than one elements of different data types. Let's see our syntax to get more clarity on this. So for the syntax, struct is the keyword we must use while defining the structures, followed by the identity of the structure. You can give any name to your structure. Then inside our structure, we'll define our multiple elements followed by their corresponding data types, like data type element 1, data type element 2, and data type element 3, and so on. At the end, it is a must to put in semicolon. Remember it. So now let us see an example to get a more clarity on this. We're going to create a structure of an employee. So we're going to create struct employee, and in our structure we are going to give employee number, which is int employee number, character employee name, and float employee salary. Here, we created a structure of an employee. In our structure, we have our employee number, which has the data type of int, employee name, which has data type of a character, and employee salary, which has a data type of float. So here you can see we have a collection of more than one elements of different data types inside our structure. So why do we use structures? So unlike the array, which holds n number of elements of similar data type, like they have to be homogeneous in nature. So an array can't store a student data type or an employee data type or so on. So for that purpose, we have our structures. You can't create a student data type or an employee data type using any other thing but structures. Now let us see how do we declare our structure inside our main function. We declare structure. Inside our main function, here we defined our structure, struct employee, and inside our main function, we are going to declare our structures. For declaring we are going to give our data type, which is struct emp. It's 2 words, okay? This is our data type. And E, this is how we declare our structure. Here E is nothing but an internal pointer variable. What does it do? It points towards the base address of our memory location. Let's start with any random address, 2046. This is how it is going to store in our memory, or this is how it is going to get a memory allocation. We are starting from any random address. E, which is our internal pointer variable, will point towards the base address of our employee structure, followed by E number occupies 2 bytes because it is of integer, so it goes 2048. And E name will occupy 20 bytes, so from 2048 to 2067, and employee salary will start from 2068. So in total, they will occupy 26 bytes of memory. Now let's see how do we print the size of our structure. First we'll start by defining our structure. Struct employee int E number char E name and float E salary. Then inside our main function, we're going to declare our structure, struct employee E, and then we're going to printf size of employee format followed by a format specifier. We're going to use a function size of, and here you're using a function size of. Inside this function, we can either use our internal pointer variable E or printf size of employee followed by a format specifier size of, or struct emp, a user-defined data type. They both are going to give you the same answer, which is the size of our structures. Now let us see what are global structures and what are local structures. So, as the name suggests, a local structure is a structure which is defined inside a function or a method. So it cannot be accessed outside that function, okay? And a global structure is a structure which is defined outside a function so that it can be accessed globally anywhere. For example, let's give our function, this is our main function, and this is our check function, maybe. So if we create a structure inside our main function, and let's give only 2 variables, int A and B. So this structure we have defined inside a function or a method. So it can't be accessed outside this function. If we try to define it here, struct local L, it will say error. because the structure is defined inside this function. But in case of a global structure, we can declare it anywhere. This is correct, but this is wrong. Now let us see how do we give an input to our structure. We start by creating our structure, struct employee, int enumber, char ename, and float salary. Now inside our main function, void main, and to define our structure, struct emp e is equals to 1001 Rahul This is how we give an input to a structure. The order of the input should be same, like first the E number, then the employee name, and then the employee salary. And we know that the character should be always in double quotation, no matter what programming language it is. Finally, we are going to print tails and printf %t e %s and %t sal. And this is how we are going to get the output, like employee name followed by the format specifier and e.e number, then employee name followed by the format specifier, which is %s, and e.e name and employee salary followed by the format specifier and e.e salary. It's your choice how do you want to print it.
We are going to talk about pointers in C. So, pointers in C. So the first thing that comes into our mind is, what is pointers? So pointer is nothing but a variable whose value is the address to another variable. That is the direct address of a memory location. Or you can say this, the pointer is used to access some information from a particular memory location. Let's start by seeing its syntax. So you guys already know how to declare a normal variable, right? So what is the syntax for declaring a normal variable? The syntax for that is data type and then the identifier, right? This is the syntax of declaring a normal variable, right? So that example for this is, suppose we are declaring a variable int n. Suppose int n is the variable. This is how we declare a variable, normal variable, right? Now to convert this normal variable into a pointer, how we can do that? Let us see. After the data type, if I add a star here, right here also, the syntax as well, the example of the syntax, this is how a pointer looks like. Now this normal declaration of variable is converted into declaration of a pointer. So this is how a pointer is written. The other form of declaring a pointer is int star n. So either you can put a star just after your data type here, or you can just add a star just before your variable's name. So these are the two types you can declare a pointer, right? So in this case, this is the syntax of a pointer. So it is very simple. Just data type, then star, then your identifier or your name of your variable, whatever it is. So now let's see the different types of pointers. So there are only two types of pointers. There are only two types. First type is, I'll write here, typed pointer, and the second one is untyped pointer. Now what is the difference between typed and untyped pointer? Let me explain you. Here in the typed pointer, this typed pointer points to a specific type of data. What does this means? Example for this is, this typed pointers points to a specific type of data. That means, let's say int kind of data will only points to the int data. Got it? Float type of pointer will only specify to, only points to float type of data. Now there is a structure data as well. So suppose it is struct student pointer. Now this will only point to the student type of data or student data. So here typed pointer points to a specific type of data. That is, suppose if it is an int type of pointer, it is only going to point towards the int data, or if it is a float pointer, then it is only going to point towards the float type of data. And if it is a structural type of data, or you can say structure pointer, there is a structure pointer also. So structure student pointer, it is only going to point towards the student data here in this case. Now what is untyped pointer? So untyped pointer can point to any kind of data. So here typed data is only going to point towards that particular kind of data, but untyped data, untyped pointer, can point towards any kind of data here. This is also called generic pointer. Got it? This is also called generic pointer just because it can point towards any kind of data. Example for this is void pointer, void star. It can point towards any type of data. Understood this difference? There are two types of pointers. First one is the typed pointer, the second one is the untyped pointer. Typed pointer can only point towards a specific type of data. That is, suppose if it is an int type of data, then it is going to only points towards the int data. Float type of pointer will only points towards the float data, and struct type of pointer will only points towards that particular kind of data. So struct student pointer will only point towards the student data. Now the point to remember here in typed data is that int type of pointer cannot point towards the float data, or float kind of pointer will not be able to point towards the structural data, or struct data cannot point towards the any other type of data. It only will be able to point towards that kind of data. In untyped pointer, it can point to any kind of data. That means it is a generic pointer. So it is also called a generic pointer. Example, void pointer. So void pointer can point towards any kind of data. Now, whenever in pointers concept, whenever we do any kind of operations, we use only two types of operators. The first one is the ampersand or the AND operator or the address operator, and the other one is the pointer operator. So these are the only two operators that we use when we do the pointers. So this is what we call address operator, and this is the pointer operator. So what does this address operator does? Suppose this is the memory location. Okay, so suppose we have declared something as I equals to 50. Okay, so this is I equals to 50. So when we declare this, let's say int I equals to 50. So what is happening here? Computer will allocate a memory location with name as I and the value will be 50, and there will be some kind of address to this particular memory location. Let us say anything. Let's say 2160. So this 2160 is the address of this particular box, this particular memory location. So this is the address of this particular memory location. So if we use ampersand I or and I, and if we print and I, then it is going to return this value 2160. This is the address of this particular memory location, which name is I. So we have allocated I equals to 50. So 50 is inside this memory location, but the address of this memory location is 2160. So this is what we call the address of the memory location. And ampersand, or you can say address operator, is used to get the address of this particular memory location. But what is this pointer operation? If this pointer operator will points towards the value of this particular memory address. So if I write here pointer I, if I print pointer I, then what will happen in this case? This is going to return from I equals to 50, this is going to return the value 50. Why? Because it is pointing towards this address of this particular variable. So this pointer operator will give us the value 50. Why? Because it is pointing towards the address of this value, this variable, and it is going to print the value which is inside this particular memory address. So 50 is the value of this particular address, so it is going to print 50 here. So this is the main difference between the address operator and the pointer operator. So I hope you have understood this very well. Now let's see an example and understand pointer concepts a little better. Now let's see the example for this. So suppose I'm going to write a program. We have void main, and inside a void main I am going to declare a variable. So let's say int, let's say I equals to 50. Let's say when I declare a variable, computer will allocate one memory here. So the name of this memory will be I. The value of I is 50, so here the value will be 50 in this box, and there will be some memory address for this particular memory location. So let's take anything. Suppose 2016. Suppose 2016 is the address of this particular memory location for this declaration for I equals to 50. Now I am going to declare a pointer. So let's say int star. Now I can use anything for the pointer's name. So in this case, I'm going to write here ptr, semicolon everywhere. Now you can see I have declared a pointer. So here in this case, computer will again make a memory location for this ptr, and there will be again some address for this particular memory location, right? So let's say 3016. 3016 is the address of this ptr memory location. Right now we don't have anything into this ptr, so let's put something into it. Let's say ptr equals to ampersand of I, or I have written and of I. And of I, that means this is the address operator and I'm using I in this case. So what this ptr will contain here, the value of ptr will be the address of this I. Why? Because I have written ptr equals to address of I, right? So the value of this ptr will be 2016. So inside this 2016 will be the value of this ptr, and this 2016 is stored under this particular address of the memory location, so 3016. Now with this pointer is pointing towards this memory location of I. After this, why? Because I have given the value as of ptr as ampersand I. So now this ptr is pointing towards this address of I, which is 50, right? Just because I have given the value of ptr to be address of I. Now this pointer is pointing towards the address of this particular memory location of variable I. Now I'm going to print here some things. Let's say printf %d. First I'm going to print, let's say I. Okay. So with this %d I, what will be printed here? The value of I, which is 50, right? This is going to print 50. Now I'm going to print here printf %d ptr. Let's say ptr. So what is the value of ptr here? 2016, which is the memory address of this memory location, right? So this statement will print the value of ptr, which is 2016. 2016. Again, after this, I'm going to print some things. Printf %d. Now I'm going to print the address of this I. So what is the address of I here? Again 2016. Address of this particular memory location 2016 again. Now again I'm going to print the address of ptr. Let's say what will be the address of ptr? Address of ptr will be 3016, right? Because this is the ptr value 2016. What is the address of this ptr? Address of this ptr is this 3016. So 3016. Now let's again print printf %d. Now let's print pointer of ptr. Now what is this pointer of ptr? What will be the value for this pointer of ptr? Pointer of ptr will be 50. Why? See, pointer of ptr, pointer of this ptr, that means what is the pointer of this ptr? Pointer means the value which is stored inside this ptr, which is 2064, right? And it is pointing towards this address, which is I's address, right? So 2016, in 2016, what is written here? 50, right? So it is going to print 50 in this case. I hope you have understood this one well. Pointer to ptr means pointer of the memory location of this pointer. So the value of this pointer is 2016. this 2016 is pointing towards this memory location, and what is the value of this memory location? The value of this memory location is 50, right? So 50 came here. Again, now I'm going to print %d and pointer of ampersand of I, or the pointer of the address of I. So I've written pointer and I. So what will be the value of pointer and I? So first let's see the inside part. And I means the address of this I, that is 2016. And what is the pointer of this 2016? Pointer, that means the value which is stored inside this 2016, which is 50 again. So this is going to print 50 again, and our program is completed. So this is a small example about pointers. I hope you have understood this. What we have done here is, let me tell you, first we have initialized a value of I as 50. So in the computer, it created a memory location as 2016, or any location, any address you can say. 50 is the value of this particular memory location I. Now the address of this I is 2016. Then we initialized a pointer int star ptr. So when we initialize this pointer, again for pointer, it allocated a memory location as 3016. Inside this 3016, it was empty till now. Till here, till this point, it was empty. This is done. This is done. We are not done this. So till here, till this point, this is empty right here. PTR doesn't contain anything. So it just allocated a memory location for PTR, and the address for this memory location will be 3016. It can be anything. We are just supposing 2016 and 3016 as for the example. It could be anything, we don't know. So 3016 is the address of this PTR and 2016 is the address of this I. After this was empty, so we put ampersand I into this pointer. Ampersand I means the address of I. So what is the address of I? 2016. So in the value of PTR will be 2016 in this one. Then we started printing our first thing. So we printed I, right? So the value of I is 50 in this case. So 50 is printed. Then again we printed pointer. So what is the value of this pointer? Just because the value of pointer was address of I. So address of I is 2016. So 2016 came inside this pointer. Now we came to this step and we printed address of I. So what is the address of I? Again, address of I is 2016. So 2016 has been printed right here. After this, we printed ampersand PTR or address of PTR. So what is the address of PTR here? 3016, right? So 3016 got printed here. Then we printed pointer to PTR. What does this pointer to PTR means? Pointer of this PTR. That means this pointer was containing 2016, right? Now 2016 is pointing towards this memory location. And what is the value of this memory location? 50, right? So it is going to print 50. Got it? Now in our final statement, we printed pointer of address of I, star of and of I, or you can say pointer of address of I. So in this case, what is the address of I? 2016 is the address of I, this variable right here. And what is the pointer? What is this pointing towards? This 2016 is pointing towards this value that is inside this memory location, which is 50. So again 50 got printed, right? So this is the example. And one more thing that is very important that you need to keep in mind is that we are using %d here in the print statement, right? But whenever we are printing the address will be in positive value only. Address cannot be negative value. These memory location, these addresses of this memory location cannot be in negative value. So it can't be negative of 2016 or negative of 3016. Address of this memory location should be only positive. But here we are using %d in our every print statement. %d can return a negative and a positive value both. So in this case, whenever we are printing the address of the pointer, address of the memory location, we should always use %u. %u. Here also %u. So to make sure that our address will be always in positive value. So what is this %u? %u means unsigned value. So %u means unsigned. So this is going to only return the positive value for all the addresses right here. In today's video, we are going to talk about preprocessor directives in C. So before starting this video, I would like to request you people to please like, share and subscribe to our channel Coders Arcade and press the bell icon so that you won't miss any future updates. So with this, let's continue our topic, which is preprocessor directive. So what do you mean by preprocessor? What do you mean by this word? Preprocessor is nothing but a program that preprocesses the source code. So this is our source code. Okay. So it preprocesses the source code before the source code is going to be compiled. So this is the compiler. Okay. So this is our source code. And before compilation, this preprocessor is going to preprocess the source code. Okay. So this is our preprocessor, let's say. This is our preprocessor. So first the source code will go to the compiler, and then this source code is first preprocessed by this preprocessor here, and then again this code will go back to the compiler, and then now this source code that is already preprocessed will compile now. Here in this case, source code will not be compiled here, but after preprocessing only this source code will get compiled. Then this code will be in the final form of assembly level language code. Assembly level language code. So preprocessor is nothing but a program that is used to preprocess the source code before compiling that particular source code. So in this case, you can say preprocessor is nothing but the text substitution, or you can say text processing tool. So basically, preprocessor is nothing but the text substitution or text processing tool which is used to preprocess the source code before that source code is going to get compiled by the compiler. Now after it is compiled, it is converted into the assembly level language code. So some basic example of preprocessor are, the very basic example, you always write #include, this #include stdio.h before starting our C program. So this #include stdio.h, this #include is nothing but the preprocessor directive in this code. So this is what we call a preprocessor directive. So with this line, our source code will be first preprocessed and then it will be compiled afterwards, and then it will be converted into assembly level language code. So now the points that you need to remember in preprocessor directives in C is that a preprocessor is not the part of compiler. It is not the part of the compiler, but it is not the part of the compiler, but it is the, first of all, it is not the part of the compiler, but it is the step in the compilation process. Got it? So it is not the part of the compiler, but it is the step in the compilation process. That is very important, because preprocessor first preprocesses the data, the source code, then it is gone to the compiler. Always preprocessor starts with a # symbol right there. So #include stdio.h. Now there are so many hash defined. We have hash include stdlib.h, hash include process.h, or hash include math.h. So there are so many preprocessor directives. So this is the basic structure, or this is the basic definition of preprocessor. Basically, it is a program that is used to preprocess the source code before that source code gets compiled by the compiler. It is nothing but the text substitution or the text processing tool, and it is not the part of the compiler, but it is one of the steps in the standard compilation process. Example for the preprocessor directive is hash include stdio.h. So in this case, hash include is the preprocessor, and preprocessor always starts with hash symbol. Now let us see different types of preprocessor directives. Actually, there are totally 11 or 12 preprocessor directives that are important, and you might be tackling those preprocessor directives many times. So let us see. Here I will write example. We have hash include, the most used one. Everyone knows about hash include. Then we have hash define. Then we have hash if. Then we have hash else. Then we have hash elif. Then we have hash if def. Then we have hash undef. We have hash endf, endif. Then we have hash if and def. Then we have hash error. Then we have pragma, hash pragma. So these are the important types of preprocessor directives that you are going to see in C programming. So these are the main preprocessor directives right here. Got it? Now preprocessor directives are of three types. So basically they are of three types. What are the three types? The first one is macro substitution directive. Macro substitution directive is the first one, first type of preprocessor directive. And the second one is file inclusion directive, file inclusion directive. And the third one is the compiler control directive. So we have three types of preprocessor directives. The first one is the macro substitution directive. Then we have the file inclusion directive, and then we have the compiler control directive. So this is all about preprocessor directive as an introduction. Now let us see these three types of preprocessor directive. So basically I'll give you an idea what preprocessor directive is. As you can see here on the board, that preprocessor directive is nothing but a program that preprocesses your source code before it gets compiled by the compiler, and then it is going to convert into assembly language code. Preprocessor is nothing but the text substitution, or you can say text processing tool, that is used to preprocess the source code. Now the main points that you need to remember while preprocessor in this topic, preprocessor directives, is that it is not the part of a compiler. It is different from the compiler, but it is one of the steps in the compilation process in C language. Now the basic example for that is hash include std.h. Then these are the important preprocessor directives that you will be tackling when in this topic. So we have hash include, hash define, hash if, hash else, hash elif, hash if def, hash undef, hash endif, hash if and def, hash error, and hash pragma. So basically hash include is used to include the files, hash define is used to define the macros, hash if is used to test the compilation time, then hash else is just the alternative of hash if, Then hash elif is just the combination of if and else, hash if and hash else in just one statement. So that is hash elif. Then hash if def is the starting of the conditional statement. Then this hash undef is the undefined, this is used to undefine the macro that is defined by this hash define. Then hash endif is used to end the conditional statement, the conditional the preprocessor. And then we have hash endif, and this is used for the again this is used for the conditional statement. Then hash error is used to print the error message, and hash pragma is used to, is as a special command in the compiler. And these are the three types of preprocessor directives that we are going to discuss in this video again. So we have the macro substitution, then the file inclusion directive, and then the compiler control directive. So these are the three. Now let us discuss about these three types of preprocessor directive one by one. So let us talk about the first type of preprocessor directive, which is macro substitution directive. So what does this directive does? So macro substitution directive, what it does is it replaces every occurrence of identifier with predefined string. What do you mean by this? What do you mean by replace every occurrence of identifier with predefined string? So let me tell you. I'll explain you with the syntax. So the syntax here is hash define. To define a macro, we use hash define, then the identifier, and then the string or the predefined string. You can say that predefined string. So the syntax for this is this. So what is happening here? Hash define, we defined some identifier and we are using some predefined string that is going to replace this particular identifier. That means, let us see an example first. We have, let us say, I'm going to write here hash define. Let us say sum of x comma y will be replaced with x plus y. This is one of the examples. So now here what is happening, I have written hash define. So using hash define, I'm defining a macro, and this is the identifier. Sum x comma y is replaced by x plus y. So wherever in our program, down in the program, wherever there is sum of x comma y, that will be replaced with x plus y. Let us see this with an example. But before that, I'll give you one more example. Let us see another example. Hash define. Let us say I write SQR in capital and in bracket x. So this SQR, x will be replaced by x into x. All right. So this is our first example and this is our second example. So now in this program, wherever SQR, capital SQR in bracket x will be there, that will be replaced with x into x. So we can use this to replace identifier with a predefined string. Now let us see and understand this logic with the help of an example program. So the example program. So first of all, we will start again with the hash include statement. So hash include stdio.h. Then I'm going to define a macro. So for that we have hash define. And let us take the first example. Sum of x comma y will be replaced with x plus y. Right? X plus y. So there is one space here and one space here. Okay. Now we will write our main function. So void main. Inside our main function, I'm going to declare a variable called s, and using this s, I am going to do this, which is sum of, now instead of x comma y, I will give the values, which is, let us say 10 comma 20. So this is inside this s. All right. Now in next step, I am going to print it out. So printf sum is %d s. What does this means? And this is closed. We closed our program. So what we are doing here, what will be the output for this program? Can you tell? First, I am starting with my preprocessor directive hash include, and we included this file. Then we have defined a macro, so hash define, then sum of x comma y, and this will be replaced with x plus y. So in this case, in our main function, when I declared my first variable s, and then I use that variable in this formula, in this identifier that I'm using here. So sum of 10 comma 20, here sum of x comma y. So in this, value of x is 10 and value of y is 20. So this will be automatically replaced by x plus y. So we don't have to write here in this part of the program, we don't have to write 10 plus 20 or x plus 20, x plus y. We don't have to write this. This is okay for us. So we don't have to write this. We don't need this. Okay. This is just fine. And then I'm just directly printing sum is %d and directly printing this s. So my output will be, output for this program will be sum is, what will be the sum? The value of s will be 30. So this will be our output of this program. So using this macro, we don't have to write any formula. Just in this case, I've used this identifier as sum of x comma y. See, x comma y is 10 comma 20, and it is automatically replaced with this logic, but we are not writing this logic, so we don't have to write this logic anymore. We don't need this. All right, so there you go. This is the program for macro substitution directive, and this is our main point of focus. So this is our program, and this is our output. So this is what we call macro substitution directive. There we go. So I hope you have understood this. Now let's move on to the other one, which is file inclusion directive. So now let us talk about our next one, which is file inclusion directive. So what do you mean by file inclusion directive? As the name suggests, this directive is used to include files. So example for this is, we already know, hash include, we write stdio.h, right? So this is an example. So we are including the stdio.h file here. Now the main point to be remembered here in this file inclusion directive is, there are two types of files that you can include using this file inclusion directive. So there are two types of files that can be included. Okay, so what are the two types of files? The first, header file, you can say, we always say header file, or you can say standard file, the main header or the standard file, like the stdio.h, the process.h or math.h. The second one is user defined file. So let us discuss about these two again. So in this file inclusion directive, we have, it is used to include the files. For example, hash include, we are including this stdio.h. Now there are two types of files that can be included using this file inclusion directive, and the first one is the header or the standard file. Now this header or the standard file are the predefined files. These are the predefined files. What do we mean by predefined files? I'll tell you, but the second one is the user defined file. So user defined files means it is user defined. Again, it's user defined. So what all this header or the standard file contains? Predefined files means files such as stdio.h. We have this file, then we have math.h, then we have process.h, then we have stdlib.h. So many, there are so many. These are the header or the standard files. These are the predefined files, right? These are the header or the standard, the first one. Now the second one is the user defined files. So what are user defined files? So as you can see here, user defined files. So user defined files are nothing but like you can say when you have a very large program, when you have a very large program, suppose around 200 to 300 lines of code, good practice is that you should divide that program into small parts, and then you can include those parts into this user defined files. So in this case, you can say the syntax for including user defined files is, you can write like #include, and after that #include, you can just write in double quotes your file name. There you go. So this is how you can include the user defined file. So your own file or any user defined files. So it can be any program file, it can be any type of file, but it should not be the predefined file. So predefined files such as these files, if it's a predefined files, then it is always written in arrow brackets, and if it's a user defined file, it is always written as double quotes like this, and inside that your file name will be present. So now let's see the different syntax for writing header files and user defined files. So including header files and user defined files. So generally the syntax for header file is, including header file is #include, and inside our arrow brackets your file name will be present. Here your file name will be present, but for the user defined, syntax will be #include. Instead of using arrow brackets, here in double quotes your file name will be present. So like this. So the syntax for including header files is #include in arrow brackets file name, and for user defined files, syntax for including user defined files is #include in double quotes you will write file name. So this is all about file inclusion directive. Now let us understand this topic with the help of an example program. So let us see an example program. Example program for file inclusion directive. So let us see. To include a basic file, we always start with #include. These are the header files, stdio.h. Okay, now #include stdio.h. Then I'll directly write my main function, void main. And inside my main function, I will just printf. Let's say Coders Arcade. Coders Arcade. We are going to print Coders Arcade into our print statement, and then we'll close our program. We'll close our main function and we completed this program. So can you tell me what is the output for this? What is the output for this? Output will be Coders Arcade. So here in this case, we are including this file, stdio.h. What is this stdio.h? This stdio.h is nothing but standard input and output file. So standard input and output file, what this means is this header file, this stdio.h contains keywords such as printf, scanf, and many more. So this stdio.h is the standard input and output file, and this file contains printf, scanf, and many more keywords. So in this case, if we don't include this stdio.h, this printf won't work and it will give us an error. This program won't execute without stdio.h. So there are different files. So this is the predefined, or you can say the standard header file that we included in our program. So this is the main reason. That is why this is the main reason we include these kind of files. All right, to support these keywords and support different part of your program. Now there are so many files, so many types of files that you can include in a header file. As I have told you before, stdio.h is one, math.h is another, process.h is another, stdlib.h is another. So these are the various different files that you can use to include according to your program requirement. So these are the standard header files. All right, so with this we have completed our second type of preprocessor directive, which is file inclusion directive. So our main point of focus in this one is this #include stdio.h. So #include, this is our file inclusion directive right here. So #include is the main file inclusion directive. Now let's move on to our next one and the final one, which is compiler control directive. So now let us see that. So now let's talk about compiler control directive. This is the third type of preprocessor directive that we have in C. And what is this used for? So basically, compiler control directive is used to select some particular part of a program and then compile it. You can use this directive to compile some specific part of a program, or you can skip the compilation of some specific part of a program according to your requirement of the program. So let us see the syntax for that. Or first let us see the directives which are used in this compiler control directive. So directives such as #if, all the conditional directives. So #if, #else, #ifdef, #ifndef, #undef, #endif, all these kinds of directives are included into this compiler control directive. So let us see the syntax for this kind of directive. So I will use ifdef here. So I will start my program by #ifdef. Then here comes our macro name. So macro name. Inside our program, there will be many statements. Statement 1, then statement 2, then statement 3, and so on till statement n. And then we will end our program. So by using this endif, because we started ifdef and now we'll end it using endif directive. You will understand this kind of directive properly when I'll show you the program for this. So basically, compiler control directive is used to partially compile your program or select a particular part of a program. You can compile that part of a program, or you can select what part of your program you don't want to compile, and then you will proceed according to your program requirement. So in this case, we have all these directives for the compiler control directive, and this is the syntax for this compiler control directive program. Now let's jump directly into the example program and understand better about compiler control directive. So now let's see the example program for this compiler control directive. So as usual, I will start my program with #include what you might know now, stdio.h. Then I will define a macro. So #define. Let's say my macro name will be line. Okay, line, and I'll replace this with 1. You will get to know why I'm doing this. Now we'll create our main function, void main, and inside our main function, I will start my #ifdef. Ifdef line. What does this mean by ifdef line? We'll see. I am starting with ifdef line, and then if line. Line means if now this macro will swap line with this 1. So if 1, then printf the line is 1. Else, #else. I'm using else #else directive. #else printf the line is 2. Okay, then I will just end it. So how I'll end it? #end if, and I'll close my main function. So here is the example program. Now let's dive a little bit deep and see what's happening here. So this is our #include stdio.h. We are including this so that we can access printf function right here, and that this is very important. So it's the standard input output file. Then I've defined the macro. So line and 1. So line will be swapped. The line in this whole program will be swapped with 1. So in our main function, ifdef line means line will be swapped with 1. So here in this case, the value of line, this will not be there. I mean to say is, instead of line, just because we are using #define line 1, instead of line, it will be swapped with 1, and then in printf, if it is 1, then it will say the line is 1. If it's not 1, then else printf the line is 2, and then end if. So what is happening here? Here, if def line value will be 1, so this line will be swapped with 1. So since it is 1, then output, what will be the output? Output of this program. What is the output of this program? Output of this program will be the line is 1. So the line is 1 will be printed into your terminal. Why this is printed? Because here in this case we swapped the line with 1. We swapped this identifier line with this predefined string which is 1, correct? So this will be printed, this will be executed, but this won't be compiled. This will be compiled, but this won't be compiled. Why? Because our condition is true in this case only. So it will skip the part and it will end the ifdef like that. And with this, this line is 1 will be printed here in this case. So with this, we have come to an end with our topic preprocessor directives in C programming. So we discussed about preprocessor directives. We discussed about what are the preprocessor directives. We discussed about how they work, what is a preprocessor directive, and what are the types of preprocessor directives. So there are 3 types of preprocessor directive. The first one is the macro substitution, and the second one is the file inclusion, and then the third one is the compiler control directive. So this is all about this video, guys. I hope you have understood this. If you have any doubts, please tell us in the comment section below, and we'll try to solve your doubts as quickly as possible. And if you like this video, please like, share and subscribe to our channel Coders Arcade and press the bell icon so that you won't miss any future updates. And thanks for watching. This is Ashank David signing off. Happy learning.